All right, we're going to be talking today about logarithms. And logarithms are are very closely related to exponential equations or exponential functions. A logarithm, so in an exponential function, I've got a base, I've got an exponent, and that's equal to a product. So I've got my base, the exponent, and of course that equals the product. Well, with a logarithm, the base stays the same. We say log, and here is our base. We use a subscript. With that, we have our product. We take the log of a product, and our answer is the exponent. So our answer is the exponent, and we take and we are rather than rather than multiplying some base multiple times, we're asking what what exponent on that base will produce a given product. So for example, if I were to say log base 2 of 32 is 5, this is equivalent to saying 2 to the fifth is equal to 32. Base to a power is equal to a product. Base to a power equals a product. So some of the first things that we're going to end up doing is going back and forth between exponential and logarithmic notation. And part of that is notice that you're always starting with the base. The base stays the same. So if I have like log base 5 of 1/25 is equal to -2, the base stays the same. So no matter what, its base to an exponent is product. So in some ways we can spiral. We can kind of use a spiral to change this because we always start with that base. So here I've got 5, move to our exponent. In this case, it's -2. And then we've got our product here would be 1/25. Same thing happens if I decide to start with something in exponential form. Say I've got 3 to the fourth is equal to 81. Start with the base and and here I can move to the product. So I could say, okay, log base 3 of 81 is equal to 4. Log, or so 3 to the fourth is 81. 3 to the fourth is 81. This is the same, so we can use this spiral method. Always start with the base of always start with the base, either the base of the logarithm or the base of the exponent, and move to the opposite side. Because here, if I'm starting with my exponential form, my answer is the product, and and then I'll say, oh, then I'll move to the exponent. Because in a logarithmic form, I'm taking the base of the product and the answers that exponent, I always want to end back where we started. So we're kind of going back and forth. 3 to the fourth is 81. So this really shows you kind of the differences between these two and one convenient technique for converting back and forth. Now, there's a bunch of things that we're going to do with logarithms. One thing that you can end up doing is you can end up doing things like you can solve equations. If I were to say, okay, log base 4 of x is equal to 3. I can solve an equation like this by we could take this and convert to our exponential form. So 4 to the 3 equals x. Oops. So 4 to the third power is equal to x. And this, I've already got my exponent, or I've already got my variable isolated. I just need to evaluate this. 4 to the third power would be 64 is equal to my x. A couple other special things with logarithms to note is is if there is no stated base, we're going to say it is a base 10. And this is what we call a common logarithm. So say I've got log, I'm not going to state a base here, and I'll do log of 1,000. And this would equal 3 because 10 to the third power, no stated base means I'm going to assume that there's a 10 there. 10 to the third is equal to 1,000. There's also a specific base that's going to be very, very useful to us in the future. There is base E. Logs are called natural logarithms. And they're written with this notation of ln, it's natural log. So E is a special number. So if I were to say something, I could say, okay, well, I could have, and yeah, I would just say something like natural log of 5 is equal to something. And I honestly don't know what that is off the top of my head, and I would need to actually go off of here, but a lot of your calculators will have your natural log. Some of them might have natural logs and not logs. So if we're to say, okay, and actually I'll approximate this. So natural log of 5 is approximately 1.609. E is a special number. E is what we call Euler's number. E is approximately equal to 2.71828 and a lot of change. It's Euler's number. And E has some very special properties. It's what we call a transcendental number. It shows up all over in nature, kind of like pi does. It's one of about, I want to say, five different transcendental numbers that we run into. Okay, that's about all I have right now for just a very quick introduction on logarithms, and I will see you in the next video.